Hi, welcome to Tunze Tech Tips. I believe this is episode 4. Today we'll talk about the Osmolator, the 3155. There's a lot to cover on this video, a lot of troubleshooting and installation errors that I want to go over. And let's get started. The heart of the 3155 Osmolator is the controller 5017. The way this controller works is we have an optic sensor that's our primary sensor that would point down in the magnet holder that's going to read our water level. When the water is about to the point that the cone transitions into a cylinder, that's the on and off point. It's accurate to within about a millimeter. This is our backup switch. It mounts this way. When the float's raised, we get a too high alarm, and that's an override that kills the delivery of water if the optic sensor were to fail. And then additionally, inside the controller, we have a 10-minute pumping time limit. If the pump runs 10 continuous minutes, it shuts itself down, the too low light comes on. Inside the controller, you can see that everything is replaceable. The optic sensor unplugs with a 4-pin plug. Since just about a week ago, if your Osmolator is newer than 2021, you can purchase this part. It's part 5017.300. I believe they run about $26 now. The float switch is also available as a spare part. It's the same one the Nano Osmolator uses. We do have some user settings in here. These are covered in the manual, but you can adjust the pump speed. This is very important to understand because from the factory, it'll generally be set about in the middle. If you have a nano tank, you're going to want to turn that all the way down to nano, because one thing this controller does is every time it powers up, it's running a series of self-checks for about 25 seconds. Part of that is to deliver water for 15 seconds so the installer can make sure the pump's primed and operating. Another reason to do this is it always overfills for 5 seconds. And that's because with this pump, it does make some noise, and we wanted to reduce the number of off and on cycles. It's only adding about a tablespoon of water, but if you have a very small system, that could be an excessive amount of water being added. Then the other user setting in here is the alarm. I point this out because from the factory, the alarm is set to only trigger for too high when the float's raised. If you move it to these top 2 pins, you have an alarm for too high and too low. And if you move it to just 1 pin, which basically it's not connecting anything, you have no alarm. The reason you might want to do that, a lot of people remote install this float switch on another magnet as a way to be able to turn the return pump off to feed or do maintenance. You could also just disable the alarm, and that generally will be a safer installation because the float switch will still be on the same single magnet next to the optic sensor. First thing we should discuss is just a general overview of Osmolator function, and the 2 most common error lights that are just normal. Too high. Too high happens when the float switch is raised. It can also happen if the float switch is affected by a magnet. This is a magnetic switch. The black ring in the bobber is a magnet, and it's flipping a switch inside the post. If it's too close to another magnet, say you're using the optional float switch magnet, and then you have the optic sensor on the optic sensor magnet, or the magnet that holds both sensors, and those are too close, that can trigger this float. It can also prevent the float from working, so we always want to manually check that that cycles and works properly. The float switch does disassemble. I raise this point because even though it's rare, sometimes tube worms build up in here. You may need to service it. But more importantly, if you take it apart, keep in mind the orientation of the black ring towards the C-clip. If you reverse this, you reverse the direction of switching. So now it switches when it's down and causes an alarm, and stops alarming when it's up. So we need to make sure that's correct. Otherwise, it's possible the wire's damaged. There are 2 fairly fine wires inside this cable. You might check that there's no physical cuts. simple things happen, cat gnawing on the wire, dog gnawing on the wire gets pinched in the door. Check the wire carefully. Then the other common everyday issue is the too low light. If you have the too low light, that means the last time the pump was on, the controller triggered it for 10 continuous minutes and it's timed out. That's reset by unplugging the power, unplug at the controller. If you unplug at the wall, you're gonna have to wait a minute or two for the power supply to discharge. Same if you switch off the outlet. But if you unplug at the controller and plug it back in, it's an instant reset. It has 10 minutes to fill. If your pump speed was set to nano, depending on head pressure, you'll get about 1 gallon to 1.5 gallons. If your pump speed was set to max, you'll get about 3 gallons. Factory settings usually about 2. So if it's not filling, once we reset it, check your pump. Make sure the pump is adding water. Not just that the pump's running, but that water's coming out of the hose. If not, try tipping the pump upside down. Purge any trapped air. Once you purge the air, if the pump changes in pitch, starts priming, pumps out water, well, that was our cause. The other thing it can be, besides a pump issue where you know maybe the pump's just bad and you need to replace it, is that it can be a issue with the water level in the sump. Say you ran out of water previously, your sump needs 3+ gallons to top off. This is a common scenario. Then you get in this vicious cycle. You add the water, you refill it, you're all frustrated. Hey, it didn't fill up. This is another safety it has. It can only pump water for 10 minutes. So in a scenario like that, you're going to have to manually cycle it until it catches up and you have a green level light, or manually add water, bring it closer, and then power cycle it and let it catch up the rest of the way. That timer resets every time it registers that the water's level, but once it's timed out, you have to manually reset it. The last thing I'd like to add is that when we discuss the pump speed setting, you know, if you turn it up, which is sometimes necessary, say you have a system over 250 gallons, you may want to turn up the pump speed. The same applies if you're using a solenoid or a switched outlet. You need to turn up that pump speed. But I do want to caution people that there's yet another error that can happen, which is the controller will power up, it flashes all 4 lights on startup, then it flashes a status light showing you the sensor test result, and then it moves on to pumping water. If when it goes on to pump water, it turns off and starts over again, that means there's an overload. And one cause of overload is having this pump speed totally maxed out. It'll turn to about the 4 o'clock position. I would regard 3 o'clock as max, and then you typically will not have this problem unless you have a wrong power supply connected or the pump is bad. Or it can also be that these connectors are shorted out from water. So getting into some other common errors that come up. One of the most unfortunate ones that I really hate dealing with is water damage. Water damage indicator is going to be the too high and the too low red lights flashing with a constant beep, 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 beep. Usually what has happened, you know, the reason I hate this one is because I always get a lot of pushback. Oh, I didn't get it wet. Oh, there's no way. It's mounted on the wall. 95+% of the time, what has happened is this power supply tip that plugs in here has landed in water. It was unplugged from the unit for some maintenance. It lands in a puddle or in the sump, and it gets plugged in wet. Now the water damage will be under this power socket, and the only way to solve that is to unsolder this socket clean underneath.
Here you can see the water damage under the power socket. While it is subtle, this whitish green film is a great example of how saltwater contact can damage your controller.
And in severe cases, you may need a new power supply. As long as it's confined to that area, I can usually repair it. You will usually see corrosion around the perimeter of this outlet, and that's your telltale. You might even see some salt around the area, that's the cause. A less common cause is that water followed one of these sensor wires into the controller, and then you will usually see the water damage where the wires enter the controller. Those two issues I can usually fix. I cannot fix something where water has affected the processor, the relay, any of these small surface mount components, because there's a large cluster of them and it's near impossible to clean accurately and get it back to functional. Plus a lot of them tend to burn out. LED damage usually can't be repaired, but I would say 99% of the time damage is confined to the bottom of that board unless the controller fell in water or was just totally dunked, splashed, or sprayed. So usually that can be solved. We're not trying to make any sort of planned obsolescence here. This is a safety. The reason the controller does this is that if there was a short that could cause it to run on continuously and would defeat all the switches, instead it defaults to refusing to run. It detects that there's a short or open circuit on the board and just refuses to operate and triggers this damage. I would say in all the years of working on this controller, I've only seen 1, maybe 2 units that there was no obvious water damage when you get this alarm. So we can be pretty certain that if you get that too high and too low with a rapid beep, somewhere along the way it got wet. One last point I should cover on the water damage indicator. This is fairly rare, but we do see this particularly in the Northeast in basement installed units or in Florida where people may install them in garages. If there's a sudden change in temperature and humidity, you can get condensation on the board. Usually that will remedy itself. A typical scenario for that is, you've got a sump in a garage, it's very humid, all of a sudden a cold front comes through, everything gets cold, water condenses on the board. Once the board warms back up and the humidity stabilizes, it'll work again. We sometimes see that in basement installs as well, same scenario. We also sometimes see it with brand new units. Say you ordered it in December, it's snowing outside, the box came in really cold, you brought in a humid house. But those issues always resolve themselves with just some waiting, and they are fairly rare. It would be a fairly extreme temperature and humidity change that would cause condensation on the board. On the topic of the magnet mount, I see this reasonably often, and I would just want to make sure we cover this. So, 2 questions that come up often: where is the water level supposed to be on the Optic sensor? It will be where the cone point transitions to a cylinder. And this is also marked on the magnet holder. You can see a wavy line there. That is the water level that'll be maintained. Now that does assume that you properly locked in the Optic sensor. The Optic sensor pulls through and then twists. You can see there's a ramp on this side. It slides up that ramp and locks into place. Do not leave that loose or your water level will bounce all over the place because the sensor is free to move and it will move up and down. Also, there's no reason to move the magnet up and down for fine tuning. This piece slides up and down around a 1/2 inch to give you a little bit of fine tuning range, and you can adjust that way. Float switch always goes on this mount. This is important because on this position the magnet field is canceled. And I also want to point out that the inside and outside magnet are different in size. One is about 2.5 inches in diameter, one's about 2 inches. They do not line up in the center, they line up at the bottom. Again, that is specifically to shield the float switch from the magnetic field because it is a magnetic switch. On the Nano Osmolator video, we went into a lot of detail about the pump, power supply, testing these other parts. It's a little less necessary with the Osmolator because we have a unit that lights up. We can tell if we have power because it lights up. Usually that's a pretty reliable indicator. The pump, we can test the same way as shown in the Nano Osmolator video, touching these wires to a 9-volt battery. We can also connect it directly to the power supply, one wire to the hole in the middle, one wire to the outer tip shell. But the pumps, usually these pumps last between 2 or 3 years. If they're not used in Kalkwasser, it's about half that if they're used in Kalkwasser. They are something that needs periodic replacement. They're a sealed unit. If you wanted a more durable pump that was serviceable, you could use the high jet pump. The other reason to use the high jet pump is you can pump up 20 feet. So if you had a basement install, that would increase you'd be able to reach from the basement to your main sump. A few things I'd like to point out while we're on the high jet and other accessories. We do offer a solenoid that can connect to this unit, but I feel obligated to clarify that the point of that solenoid is for a gravity feed installation. If you're directly connecting to an RO unit, that is a very high risk installation, and I would have some redundancies outside of the Osmolator because a solenoid failure is not an if, it's a when. It will eventually fail, it will eventually drip, it will eventually cause a lot of problems. That's just the nature of solenoids. It's not anything specific to ours, but I think if you think to your life history with mechanical things, when your car doesn't start, usually the solenoid is the reason. The starter motor is turning over, the solenoid doesn't engage to kick into the flywheel and start the engine turning. Same with front-loading washing machines. Since that kind of became the thing, I've had more than a couple of door solenoids go out on me. And it's just the nature of the tight tolerances and the way those coils work, they do tend to eventually seize and stick. And with our purpose here, any fine debris in the water, any kind of calcium or minerals will cake up and seize that piston in the solenoid. Another option is the switched outlet. So the switched outlet allows you to use a much bigger pump. Generally, the switched outlet's only going to be applicable for a system that's above 400 gallons or has a very high evaporation rate. If you use the switched outlet, it has a fuse inside, and so if your pump isn't running, there's a 900 watt limit. You need to check that fuse, and if the fuse keeps blowing and your pump isn't over 900 watts, you may have a fault with the pump that needs to be rectified. Something fairly simple that comes up now and again is how to connect the pump. This applies to the pump solenoid switched outlet, and by the way, if you need to extend these, you can use speaker wire, but you just squeeze the clip, insert the wire, let go, and it's locked in. Undoing it is the same. I've always been puzzled by this, but I see a lot of repairs where people have yanked these off or cut them off. I've never really understood why. This is a very corrosion resistant part. Well, if it does sit in water, you can get water wicking into the wires, which will corrode the wires, but the wires are actually tin the full length. They're as corrosion resistant as wiring can possibly get. And this is just a very simple push-in connection and should be easily serviced as needed if you need to replace it, but that's how they work. So we've essentially covered the main error codes: too high, too low, water damage, which is too high and too low flashing. I should point out that the green level light might be on with that as well. If the optic sensor is in water, you will get a green level light with the water damage indicator, but the one thing you won't have is all 4 lights. And then if all 4 lights are flashing on and off in a slow pattern, that points to a overload, which is usually a bad pump or wrong power supply connected by mistake. Always check that the power supply is correct. It should be 5012.010. It's 1600 milliamps, 12 volts. This is a very common issue now because there's so many DC electronics on aquariums, and if you switch them, your pump will likely run, but much weaker, but now the controller is getting too much power. Likewise, say you switched it with an aquarium controller, that's usually a weaker power supply. The controller won't know the difference, but the osmolator will be starved for power and will give you that error. So that's where I would start, and then move on to checking that these aren't corroded or in water. Check the pump, make sure the pump is good, and make sure that pump speed wasn't completely maxed out. Okay, so here I want to cover some basic optic sensor diagnostics that you can do if you believe you have an issue with the optic sensor. One place I always like to start, you want to do this away from the aquarium, just at a workbench. I use a clothespin to restrain the float. I've got my cup of water to test the sensor. We will power up the unit. Okay, we have our green level light. That means our optic sensor passed. Now it's going to run the pump. I should point out that when you start it up, it's doing a series of self-checks. One of those is to test the sensor. When you first power it up, you will get the green level light. If the optic sensor is clean and dry, you will get a red fail light, the too low light, if the optic sensor is dirty or in water. And you can use this to diagnose your optic sensor, but you have to reinitialize every time you run the test because that test light's only on briefly at startup. Right now it shows pump on. We put our optic sensor in water. It goes to level. We can also check our float switch. By the way, the green flashing light means that it's in a time delay. It's detected that it's no longer in water. It's waiting 5 seconds to make sure that's not just a splash or wave. It does the opposite when water touches the sensor, but we can see are too high. I turned off the alarm earlier, so that's why we have no alarm. So all our sensors are functioning well, which would be expected. It's a brand new unit. But this is a way to check it. Your optic sensor needs to be shiny clean. This is a new sensor. I sometimes get some odd ones where people are insistent that there's debris or something inside the sensor. That's just not possible the way these sensors are made. This lens is put on this black cap after the wire is pushed through and the LEDs inside are wired up. There's an infrared receiver and an infrared LED inside. And then this entire unit is filled with polyurethane, so it is a sealed unit. Typically, the hazing we see is calcium deposits on this unit. I suggest white vinegar to clean them. It tends to work better than citric acid. It works faster. Citric acid tends to create I guess it's a calcium citrate salt that kind of forms a haze that's difficult to get off. If you use straight white vinegar, fill something about this size, maybe a shot glass, drop it in there for about an hour, and then just wipe it with a soft towel. This is plastic, so if you scrub it aggressively, scrape at it, scrub it with a Scotch-Brite pad or a magic eraser, you will scuff it and that will ruin the optic properties of the sensor. Another thing to point out is that this sensor, it is working with infrared. Refugium lights, grow light spectrum lights emit infrared. They will confuse and blind the sensor. It will not work. It needs to be out of the path of grow light illumination. So here I wanted to explain, in the past we always would have people send these in to have the optic sensor replaced. As I mentioned earlier in the video, now you can buy an optic sensor outright. That's part 5017.300. But as the website states, when you go to order spare parts, this should only be done on a unit made after 2021. And the reason for that is things were greatly standardized at that point. Now there's a great deal of consistency between optic sensors as well as circuit boards. And if it's older than that, you want to send it in. And this is our terminal and software and the cable where we do the calibration work. And can be quite a bit to it. So if we get into a unit that's before 2019, we typically have to change this resistor right here. This resistor controls the voltage to the optic sensor. As you see with your illumination LEDs, LEDs are always improving in efficiency. They need less power now. If you put the new optic sensor on an old resistor, it'll usually fail in very short time because it's getting too much power. So that's something that we replace here. We have to unsolder this one. It can be fairly delicate work. You need to use solder wick or vacuum and get the solder off, or you can break off those pads that it attaches to and then the controller's ruined. So if it's older, please send it in. The other thing that comes into play is our calibration settings. Here we have a readout of our sensor voltage, switch points, times. We can get in there and calibrate what point it switches at, and that'll also be very important because on older units all this was done manually. Every single unit came down the production line, they would get a reading of too high and too low, run a calibration. And while we're on that topic, when we get pre-2015, you won't have this plug. While it is not impossible to replace an Optic sensor, I strongly advise against it because now we're coming into a unit that's 9 to 10 years old or even older. We're going to see generalized failures of capacitors and different components on the board simply from age. And so it's not often a worthwhile repair. Plus, doing the repair means taking one of these sensors, cutting the plug off. I've essentially ruined the sensor for anyone else's use. And so I have to charge for the sensor even if the repair is unsuccessful, because on these old ones it was soldered in, and I've ruined the sensor to attempt a repair that may or may not be successful. Here I wanted to demonstrate one of the most common installation issues we see with the Osmolator as well as the Nano Osmolator, and that's a siphon. What most people miss is they think that the pump position is what determines a siphon. That has nothing to do with it. Here we have two containers on the same plane. You can see one's taller than the other. We've got a reservoir. The only things that are pertinent to a siphon is the water level in the reservoir versus the end point of the hose. And here I have the hose descending in here. It's a couple inches below the water level in the reservoir. And let me show you what happens. So you can see here, now we have our pump running, it's topping off. Everything seems to be working fine, but when the pump stops, water is going to keep flowing in. And the reason for this marvel of science is simply that the atmosphere itself is the pump. Walking around at sea level, I'm actually about 1,000 feet above sea level here, but you have 17 psi of atmosphere pushing down on this water and pushing it out through the hose. And as you can see, elevating the hose had no impact. It's only the end point of the hose versus the water level in the reservoir. And unless I disrupt it, water is going to keep siphoning until the end point of the hose and this water level are equal. There isn't a feasible way to loop the hose, and there isn't a feasible check valve you could use, because a check valve can't stop the direction of the water flow in the direction we intend it to and still work. So besides those solutions, the only real solution we have is to make sure this hose ends above the water level in the reservoir. As soon as we do that, there's no siphon, problem solved. But a check valve, we need the water to go that direction, so that's not a viable option. Besides that, a check valve is a mechanical device, any sort of air gap faucet check valve, that's another potential failure point. It's best to just get the atmospheric pressure on your side and stop it that way. The other thing that you need to keep in mind is that you can have a back siphon. A check valve could stop that, but again, it's another mechanical failure point. If this hose is touching the surface of your tank, we sometimes see this complaint that, hey, it tops off and then it's topping off again. When you have a lot of rapid cycle top-offs, a lot of times that hose is touching the water, it adds the water, sucks it right back to the reservoir and does it again and again and again. And that's hard on the equipment. You're also diluting the salt level because that water is going back and forth, and you're essentially balancing it out with your reservoir water, which should be just straight RO water. So I would be careful to avoid siphons when you install it, and that does tend to address a lot of potential issues.